The other day, we worked on breaking up polygons into rectangles and triangles, and that will always work, but we're going to talk about some other shapes today that we could use, and that might make our job a little bit easier. So the formula for the area of a parallelogram is the same as the formula for a rectangle. Base times height, or length times width. We mostly will talk about it in terms of base times height of the parallelogram. And then we have the area of a trapezoid. The area of a trapezoid is going to look familiar, or it should look familiar. This part right here was the equation of that midline, or that mid-segment. Add up the two bases and multiply by 1/2 or divide by 2. So we're going to do that, but then multiply by the height of the trapezoid. Or area equals base 1 plus base 2 times the height divided by 2. Like I said, we will probably divide by 2 instead of multiplying by 1/2. So let's look down here. We're going to find the perimeter and area of this hexagon. So let's plot our points. A is -3, 0. B is -3, 3. C is 1, 6. D is 7, 3. E is 7, -2. C, D, E. And F is 1, -3. So we don't have as many vertical or horizontal lines here to count for the distance of these segments. So what I want you guys to do is I want you to find the lengths of all of these. So AB, that's going to be 3 units. It's a nice vertical line. And then we have DE is another vertical line, 1, 2, 3, 4, 5. So the other 4 segments, you're going to have to use the distance formula. So take a minute to go ahead and do that. Pause the video, because at this point you should be masters at the distance formula. All right, so there is the distances for all the sides of this pentagon. So the perimeter is going to be all of these added up. 3 plus 5 plus 5 plus 6.71 plus 6.08 plus 5, which gives you 30.79. So the perimeter shouldn't be difficult to do. It may just be tedious. Now the area. So to kind of help us with the area, I'll zoom in a little bit. And like I was saying before, you could maybe break this up into a triangle here, a triangle there, a triangle there, and a rectangle there, and a rectangle here. But now that's 1, 2, 3, 4, 5 different regions. Instead, what you could do is just draw a vertical line right here. And now we have 2 trapezoids, one over here, region 1, and region 2 over there. And what I'm actually going to do is I'm going to outline these 2 trapezoids in different colors, so you can see what I'm talking about. These are the 2 trapezoids that we have. Now the bases of the trapezoids are the parallel sides. So these 2 trapezoids are kind of rotated. Where for region number 1, one of the bases is 1, 2, 3 units, and the other base is 1, 2, 3, 4, 5, 6, 7, 8, 9 units. So region 1, let's write this down here. Region 1, it's going to be 3 plus 9 times the height. The height goes perpendicular to the bases. So we're going to count 1, 2, 3, 4. It's 4 units from the bases. And divide that by 2. And if we type that into the calculator, that's going to give us 24. Now region number 2. With region number 2, we see that it shares one of the bases with region number 1, this line CF. So we count 1, 2, 3, 4, 5. So 9 plus 5 times the height 1, 2, 3, 4, 5, 6 divided by 2, and that gives us 42. That means the total area is 24 plus 42, or 66 square units. So that was much easier than breaking it up into 5 or 6 rectangles or triangles just by using the trapezoid formulas. Now let's look at the next page. It says find the value of x given that the area is 48 square inches. The area of a triangle is base times height divided by 2. We know that the area is 48. We know the base is 9, so we have to get h by itself. Let's plug these things in. 48 equals 9 times h divided by 2. We can multiply both sides by 2. We get 96 equals 9 times h. Divide both sides by 9. And if we type that in the calculator, that would give us 10.67 equals h. So we were given the area, we had to figure out the height. Example number 3 is a trapezoid where I'm giving you the area. So you'll notice that all the problems on this page, I'm giving you the area and I'm asking you to find a missing dimension. In this instance, we know that the bases are parallel to one another, and it doesn't matter which one you make base 1 or base 2 because you're adding. So our area is 100. Our base 1 is 22. And our base 2 is 10. So let's substitute those in. 100 equals 22 plus 10 times h divided by 2. Then we get 100 equals 22 plus 10 is 32, so 32 times h divided by 2. Now you could divide 32 divided by 2 right here instead of multiplying both sides by 2, and you'd get the same answer. This might be easier to do because you'll get a whole number. Up here, dividing 9 by 2 would give you 4.5, which is okay, but it's a decimal, and I know how we feel about those. But maybe just to keep things consistent, multiply both sides by 2. We get 200 equals 32h. And then when we divide everything by 32, we get 6.25 is equal to h. All right, then the last one here, parallelogram, that's area equals base times height. We know that the area is 60. They're not asking us what the base is and giving us the height. What they're saying is if the area is 60, what are some possibilities for the base and height? So we got to think about what two numbers multiply to 60. The easiest one let's maybe make a table, base and height. 60 and 1. 60 times 1 is 60. And now I'm not going to write it. I'm not going to write this as well. Just know that we could go either way. So 60 and 1. How about 30 and 2? 15. That's right. We could do 20 and 3. 20 times 3 is 60. 15 times 4. 12 times 5. 10 times 6. And that might actually be all of them. 9, yep. I'm pretty sure that is all of them. So those are the possible dimensions we could have. All right, so that does it for the day 9 notes. So you can go ahead and get started on your assignments. Thanks for watching. Make sure to like and subscribe.